With a third Starship launch on the horizon, not only are the launch infrastructure and Starship prototypes being continually improved, but another crucial aspect that often gets less noticed: the heat shield system of the Starship. So what makes it so important? Stay tuned for today's video of Elon Musk era to delve more into this. New significant enhancement for thermal tiles on the third Starship flight. Throughout all the Starship launches and tests, there have been varying degrees of heat shield detachment. Notably, during the two most recent Starship launches last year, the Starship's heat shield system failed to withstand the vibrations caused by ignition, which can be easily visible to the naked eye. However, heat shields play a vital role in the functionality of a reusable orbital rocket that must traverse the atmosphere to return to Earth. As objects approach or re-enter Earth's atmosphere, they experience acceleration due to gravity and atmospheric drag or friction concurrently. This subjects the object to severe mechanical stress and intense aerodynamic heating, resulting in a re-entry speed for space spacecraft of over 7 to 12 kilometers per second and temperatures surpassing 1,600 degrees. This combination of forces can cause mass loss, technically referred to as ablation or even total disintegration. The spectacle of shooting stars is a tangible demonstration of this process. Their bodies glow a fiery red, and spacecraft are also they can disintegrate without adequate protection. The most practical method to dissipate this energy is through a gradual deceleration via atmospheric dissipation. This process effectively transforms velocity and kinetic energy into heat, highlighting the importance of sturdy heat shielding. Some might question why retro rockets aren't utilized to gently decelerate the vehicle for re-entry. Nevertheless, the forces at play are so colossal that it would be nearly impossible for a space vehicle to carry enough fuel to decelerate adequately for re-entry, until breakthroughs such as nuclear space propulsion or anti-gravity engines become viable. The reliance on heat shielding and gradual atmospheric friction remains the only practical approach for completing the re-entry process. These shields operate by enveloping a large rounded surface with compounds that, when subjected to extreme heat during re-entry, combust. This process dissipates the heat as the material is incinerated, and a gaseous barrier forms that provides additional insulation from the heat. Nevertheless, the installation of heat shields on spacecraft is more intricate than commonly assumed. Similar to the incident of the heat shields falling off the Starship during liftoff, the complexity of heat shields is not an uncommon challenge in the aerospace industry. Looking back to the 1980s, ground crews noticed extensive tile damage after the shuttle Atlantis landed at Edwards Air Force Base in December 1988. Atlantis incurred severe damage to its heat shield, with over 700 tiles damaged or missing during STS-27. This inflicts considerable damage to the spacecraft and can potentially jeopardize the safety of the crew inside. Luckily, a steel plate absorbed most of the heat from re-entry, highlighting the crucial role of the heat shield in ensuring the spacecraft's survival upon return. The heat shields will heat up and burn away, dispersing the energy. SpaceX has acknowledged the significance and challenges of designing and installing heat shields for their colossal spacecraft. The company has come up with innovative solutions that diverge from their previous approach with Dragon. Contrary to Dragon, which depends on a heat shield that experiences ablation during re-entry, Starship requires a reusable and insulating heat shield to enable its projected rapid reusability. This change in strategy mirrors Starship's goal to land, undergo a swift inspection, and swiftly return to space without the necessity for comprehensive refurbishment. SpaceX employs fire-resistant tiles that can be substituted, akin to those on the underside and those of the iconic Space Shuttle. Starship utilizes ceramic thermal protection tiles to protect the spacecraft from the heat of re-entry. The tiles, similar to those of the Space Shuttle, are incredibly lightweight and fragile. However, unlike the square tiles of the shuttle, the tiles of Starship are hexagonal. The shape of a hexagon provides no direct route for hot gas to speed up through the gaps. Interestingly, this shape aids in preventing the heat shield tiles from detaching during re-entry, thereby avoiding chain reactions. Essentially, when a hexagon detaches, it exposes the two hexagons in the subsequent layer, but the force is distributed over half the width of two hexagons. Unlike a square grid, where the entire force is exerted on a single square. Grid or brick patterns could be employed for square tiles, and the Space Shuttle incorporated a bit of this type of tiling, but overall, it was fairly uniform. Hexagons also offer an angle to the airflow, which is intended to facilitate smooth airflow rather than tearing. Moreover, the pressures during re-entry are typically lower than during ascent for a vehicle that performs a good lifting re-entry, as per the Space Shuttle data. And during re-entry, pressure is actually at its peak at low speeds when the vehicle has descended into the denser atmosphere. Moreover, re-entry is relatively mild and smooth in comparison to the harshness of the launch and likely the flip landing burn, possibly even static fire. Well, I mean, it's hot. It's not turbulent or violent. So, assuming the tile fastening doesn't significantly weaken with heat if the tiles endure the ascent, they'll likely be fine during descent. It's also important to note that during ascent, the airflow is typically at a more favorable angle for dislodging tiles during EDL, entry, descent, and landing. Starship primarily belly flops, where the pressure largely keeps the tiles in place, particularly where the majority of heating occurs. While this may not provide much reassurance if most of the tiles are damaged during ascent, if they remain secure during the static fire and launch, EDL should also proceed smoothly as well. Otherwise, SpaceX doesn't want to glue the tiles, unlike the approach taken with the shuttle, due to the extensive maintenance time required for replacement and refurbishment. Instead, the tiles of the Starship are fastened to the stainless steel exterior using studs. Elon Musk addressed the issue of the missing tiles on the Starship by inserting a white flexible ceramic fiber mat between the rear of the tile and the Starship stainless steel. The mat is likely something akin to Cowell 3000, which can be utilized up to roughly 1,530 degrees Celsius without interruption. Even if one or more tiles detach, that mat will remain affixed to the ship. Theoretically, the structure of the Starship can thus endure and continue to function at temperatures nearing 800 degrees Celsius, while the shuttle's heat shield had to maintain the vehicle's aluminum structure below approximately 180 degrees Celsius. Indeed, up to this point, Starship has not yet attempted to withstand an orbital velocity re-entry with approximately 25,000 ceramic heat shield tiles affixed directly to its steel exterior. However, if successful, SpaceX's ultra-simplified design could afford Starship significant advantages over the shuttle. The Space Shuttle was demonstrated to be more hazardous than conventional crew capsules and roughly as costly as a comparably capable expendable rocket. The forthcoming third launch presents an opportunity for Starship to demonstrate the effectiveness of these methods. Despite some heat shield tiles detaching during tests or trial launches, SpaceX has been evolving over time, and we can observe a decreasing number of tiles falling off with each passing day. After the second Starship launch, SpaceX appears to have implemented a new design that includes new rivet positions and adding a thin steel plate to strengthen the heat shield on Starship, making it more resilient to strong vibrations when mounted on Super Heavy. Furthermore, SpaceX routinely conducts fire endurance tests at temperatures reaching around 1,650 Kelvin, equivalent to approximately 2,500 degrees Fahrenheit or 1,375 degrees Celsius, to ensure that each tile, once installed on Starship, effectively utilizes its protective properties, and that